So good afternoon, everybody. My name is Kelly Diak, and it is my pleasure to be able to present to you this afternoon. To give you a little bit of background on myself, I have spent my entire career in the laboratory, having been in the field for almost 30 years. I am a cytotechnologist by background, with my specialty having then later in my career earning my certification in histology. For the last almost 20 years, I have had the responsibility for the anatomic pathology departments for our healthcare system, as well as all things quality and regulatory related. As is the case in most laboratories, safety has always been an integral component of our quality management system. I spend a great deal of time working with our leadership team to emphasize both the importance of education and significance of employee accountability in this area. This presentation is part one of a two-part series where I will review many safety topics as applicable to the laboratory. In this first part, we are going to focus on chemical safety and then hit on several general lab safety topics. In part two, which will occur in March, we are going to talk about bloodborne pathogen safety and then discuss another set of general lab safety topics. With that in mind, the agenda for the presentation this afternoon will include the following items in relation to chemical safety and general lab safety. We will first talk about the purpose and key points of a chemical hygiene plan and safety policies. We'll discuss safety data sheets and along with that, the labeling of chemicals and the expected PPE. We will talk about splashes, injuries, and spills and what to do with them. Our discussion will then take a turn towards the storage of chemicals, and then we will talk specifically about formalin and xylene. Finally, we will touch upon chemical waste disposal, some general safety topics, and risk mitigation tactics. We're going to start by reviewing the purpose and composition of a chemical hygiene plan, as well as the need for a repertoire of general safety policies. The chemical hygiene plan is also known by the acronym CHP. It is the formal document or set of documents that define the safety surrounding all chemicals in the laboratory. It outlines how we evaluate the carcinogenic potential, reproductive toxicity, and acute toxicity of all chemicals that are used throughout our departments. It includes details about how we should handle hazardous chemicals and how operationally they are used in each setting, including what chemicals we may want to monitor or need to monitor for exposure. PPE and engineering controls must be spelled out in the CHP, including maintenance of these devices where appropriate. Assigned roles and responsibilities of the leadership team, including the medical directors, safety officers, and chemical hygiene officer, need to be clearly defined. Each of these leaders are responsible to ensure that the chemical hygiene plan is carried out appropriately and as it was intended. While you are likely not going to retype the OSHA laboratory standards into a policy or procedure, you need to have a copy of these standards available. The goal of the chemical hygiene plan is to make sure that we have a detailed plan in place to ensure the safety of our staff in regards to every chemical within the laboratory walls. This safety is not only on behalf of the leadership team, but also every employee that works in the lab. So the CHP must include details about how we communicate, train, and educate to our staff. This is essentially the quality management plan as it relates to chemicals. Your chemical hygiene plan may be one very large document, or if you feel it might be easier to address the various key components in separate documents, that is also acceptable. Sometimes when policies get too large, they are hard to use as resources, so they are broken down into several smaller documents so that they are more manageable and easier to reference. Either way, not only is it important to have a chemical hygiene plan, which is either one or many documents, it is also important to have safety policies that cover general safety issues that may not necessarily relate to the chemical hygiene plan directly, but are necessary so that staff have a resource for all safety-related items that may impact them in their role in the laboratory. Staff should be expected to read and understand and have the ability to refer to policies and procedures for all safety topics, a few of which we will discuss later in this presentation. The next topic we're going to spend a chunk of time on is the safety data sheet. These used to be called MSDS, or Material Safety Data Sheets, but within the last few years was changed to drop the M and now referred to as SDS, or Safety Data Sheets. The Safety Data Sheet is a resource every employee should know how to find and understand what they can be used for. Additionally, these should be organized in such a way that the information can be easily queried and located. Some organizations have these available electronically. Some organizations have these documents in paper. The important thing here is that if you are an organization that keeps your SDS in paper, you need to make sure that you have a usable filing system. This was in large part why our organization moved to an electronic system. We used to have binders and binders of safety data sheets, many of which were out of date and often very difficult to query when the information was needed. On the same hand, if you are an organization that has an electronic filing system, it is imperative that your staff are able to locate these electronically. As part of an auditing process, includes staff talking you through how to locate a safety data sheet via the electronic filing process. Inspectors like to ask this of staff during an inspection process, so it is important that staff are able to perform this function. So every SDS has 16 sections, which are divided into 4 major areas. On this slide, you can see the 16 sections listed. Sections 1 through 3 discuss the material and what you need to know in an emergency. Sections 4 through 6 discuss what to do if a hazardous situation occurs. Sections 7 through 11 discuss how to prevent hazardous situations from occurring. And then finally, sections 12 through 16 discuss other general useful information. We are going to walk through the contents of each section. It is important to understand all the elements that are contained in a safety data sheet because this is where you are going to find all of the information that you need to safely handle the chemicals in your laboratory. So bear with me here as we step through each section of a safety data sheet on the following slides. I do this because sometimes these continuing education sessions are the only time laboratorians are exposed to an SDS and actually can see what the various sections are. So starting with section 1, this section identifies the chemical by not only its product name, but synonyms if it has any. It also lists the recommended uses of the chemical. Contact information of the supplier is also provided in this section. We will discuss labeling of chemicals a little later, but this section is where you will find the first 2 items that are required for chemical labeling. Section 2 lists out the hazards of the chemical and appropriate warning information associated with those hazards. It is this section that you will find the hazard statement and the signal word that are required for labels that are placed on chemicals. Additionally, it is going to identify the pictogram that should be used as well as the precautionary statements that are required. Moving on to section 3, this section identifies ingredients in the product, including impurities and stabilizing additives. And then section 4 describes initial care to be given to an individual who has been exposed to the chemical. This is the section you would refer to if there is an incident in the laboratory with the chemical and you need to figure out what to do in terms of first aid. Section 5 lists recommendations for fighting a fire caused by the chemical. So this section gives you information on what kind of extinguisher to use if there was a fire involving this chemical. Additionally, as seen at the bottom of this slide, this gives you the numbers that are recorded within the NFPA label. This NFPA label is the multicolored diamond you see on chemicals in regards to health, flammability, instability, and physical hazards. The higher the number, the more of a hazard the particular item is. This is on a scale of 0 to 4. This NFPA label is not required, but you see these quite often. It is the numbers underneath each of the 4 items listed that are indicated in each of the colored spots on the diamond. If NA is listed on the safety data sheet, as is for physical hazards, the spot is left blank. So on to section 6, which provides recommendations in response to spills, leaks, or releases, including containment and cleanup practices to prevent or minimize exposure. It may also distinguish between large and small spills. This section helps give direction on what process to follow in terms of a spill. You would use this section in conjunction with your facility procedure on how to handle chemical spills. Section 7 provides guidance on safe handling practices and conditions for storage of chemicals. And we are halfway to the end of the data sheet. Section 8 indicates exposure limits, engineering controls, and personal protective equipment to be used. So this section should drive what kinds of PPE staff should wear while handling the chemical and what other kinds of equipment they should be utilizing while using the chemical, such as chemical hoods or respirators. Section 9 identifies physical and chemical properties associated with the substance. This tells you what the chemical actually looks like. And then Section 10 describes the reactivity hazards of the chemical and the chemical stability information. Section 11 identifies toxicological and health effects information. This gives you your information on the toxicity or carcinogenic potential of each chemical. Section 12 provides information regarding environmental impacts of the chemical. And then finally, the last 4 sections. Section 13 provides proper disposal practices, recycling or reclamation of the chemical or its container, and safe handling practices. Section 14 includes classification information for shipping and transport by road, air, rail, or sea. Section 15 identifies safety, health, and environmental regulations specific to the product. And then Section 16 gives some general information about when the SDS was prepared or the last known date of revision. So now that we've reviewed each section of a safety data sheet, how can all of this information be used? In a nutshell, the set of safety data sheets that correspond to the chemicals that are used in any laboratory serve as the base for what your chemical hygiene plan is going to look like and how your operational policies surrounding these chemicals are going to be formulated. To start, this information can be used by all staff as education on the chemicals that they are being exposed to and how to safely and effectively use them without creating any more risk to themselves than necessary by the nature of their job. Education on these chemicals and their properties could help avoid situations where employees are exposed unnecessarily by understanding what to look for in the event of an incidental situation. Safety data sheets are used to determine what the employee should be wearing when handling the chemical and/or what the equipment they should be using while using the chemical. They help explain the labels that they see on the chemicals in the event they are not proficient at what all the words, signs, and symbols mean. And they are a good reference for spills, accidents, and exposures that might occur. Additionally, they help determine how a particular chemical can be disposed. It is important to note at this point that the safety data sheet is only as good as the use and review of the information you have available to you. At our organization, it is often a point of emphasis to the staff that for their own health and safety, they should be educated on these points of information and should heed all warnings given to them. We encourage staff to not take the "I'll be fine" or a less desired flippant attitude with chemical safety, to know what it is you are working with, and to follow all safety guidelines set out for them. So while safety data sheets are a great resource, it is important to understand the requirements of a chemical label, not only as a means to label a chemical bottle that needs labels applied, but also to know what information you can glean from the container of the chemical in which you are working, both of which are very important aspects of chemical safety. All chemicals must be clearly labeled with the chemical name and all hazard warnings as defined by OSHA. This includes all chemicals that are purchased and used out of their original container. In this case, it is important that the existing labels on these containers are not removed or defaced. This also includes any container that a chemical may be poured into if not used immediately by the same person that poured it into that container. If a chemical is placed into another container and stored, that container, that is not the original one in which it was purchased, must be labeled with all the appropriate information. So there are 6 elements that must be present on all hazardous chemical labels. These are the product identifier, supplier identification, hazard pictograms, signal word, precautionary statements, and hazard statements. The supplemental information that you see in the bottom right-hand corner of this slide is optional to be added. As we discussed earlier, all 6 of these pieces of information can be found in the first 2 sections of the safety data sheet. Aside from the chemical name or product identifier and the supplier identification, which are more obvious pieces of information, the pictogram, signal word, precautionary, and hazard statements are more specific pieces of information we are going to review. Chemical labels must include pictograms, which visually identify the main hazards, and we're going to go over the options for these in the next slide. Signal words are those such as warning or danger. Hazard statements state what the hazard is. Examples of these are causes serious eye damage, toxic if swallowed, and may cause allergy or asthma symptoms or breathing difficulties if inhaled. Precautionary statements describe what you should do to protect yourself from the hazard. So examples of these include things like wear eye protection, do not eat, drink, or smoke when using this product, avoid release to the environment, and in case of inadequate ventilation, wear respiratory protection. So there are 9 pictograms to be familiar with. Starting in the upper left-hand corner, we see the pictogram for health hazard. This indicates a chemical that is either carcinogenic or has reproductive toxicity, among other things. Moving to the right, the next pictogram indicates a flammable reagent. The exclamation point stands for a chemical that has harmful acute toxicity characteristic, among other things. The second row starts with a symbol for gases under pressure. The corrosion pictogram is pretty self-explanatory. And then the second row finishes up with the exploding bomb pictogram, indicating an explosive or self-reacting chemical. The last row starts with the oxidizer, and then the middle bottom pictogram is non-mandatory, but when used, it does indicate aquatic toxicity. And then finally, we have the more severe acute toxicity pictogram, where exposure could be fatal or toxic. So the next topic we're going to talk about is PPE. Employees must wear the appropriate personal protective equipment when handling hazardous chemicals in order to protect themselves. Staff often cut corners here because they are in a rush or they might not feel it is convenient to don the appropriate PPE, but it is so important for them to do so, and it is important for leaders to hold staff accountable to this. It is for their safety and the safety of everyone in the laboratory. Depending on the chemical that they are working with, the staff will want to don particular types of PPE. This could be limited to gloves and eye protection. The chemical might require an impervious gown, and some chemicals require respirators to be worn. There are chemicals that must be used under a chemical hood, which is a type of engineering control. It is important to note here that a biological and chemical fume hood are 2 different types of equipment. It is important for staff to understand which hoods are suitable for chemicals. Accidents are going to happen, we know that, so we need to prepare ahead of time for these incidents. In the unfortunate event that a spill, splash, or injury occurs due to a chemical, it is important that staff are educated and prepared to act quickly so as to minimize the effect of the exposure. This is why it is so important for staff to be aware of the hazards they are dealing with, because in an emergency, you do not always have the time to pull out your available resources to figure out what to do. These should be automatic reactions so that action can be taken as quickly as possible. The most common types of chemical exposure that require immediate action are eye and skin contacts and ingestion. Depending on the severity of the exposure and the process at each organization, employee health, occupational health, or emergency departments may need to be contacted. While not a priority at the time of the exposure, once all immediate actions have been taken, all accidents must be reported and trended. The purpose of this is for process improvement. Accidents and exposures of any kind should be reported and trended throughout the year, looking at the event and identifying any trends. The leadership teams should be evaluating these instances for ways to improve or further educate. In some cases, corrective action may be appropriate. For obvious reasons, it is necessary to have an eye wash and shower where applicable in the laboratories. An eye wash and shower, where appropriate, should be available to all areas of the laboratory in which hazardous chemicals are present, and they must be available within 10 seconds travel distance. Eyewashes must be able to meet the following requirements. They must be capable of delivering 1.5 liters per minute for 15 minutes, with the flow being provided to both eyes simultaneously. Nozzles or covers must cover the eyewash when not in use to protect from airborne contaminants. The eyewash must be hands-free once the flow has been activated. So this means that you cannot have an eyewash where you need to use one hand to keep the flow running after you have activated the workflow. Eyewash locations must be identified with clear signage. There must be an unobstructed path to the eyewash for staff. So this means that there must be no locked doors in the path, and they must open in the direction of the eyewash. So staff should not need to pull on a door to get to the eyewash that is assigned to them for events that might occur. Plumbed systems must be protected from unauthorized shutoff so that they're available when they're needed. And the water temperature must be tepid. It can't be, really hot or really cold. The maintenance of eyewashes and showers is very important because you want to make sure you have working equipment when or if the event occurs. In order to ensure that your eyewashes and showers are always in working order, they should be checked weekly to ensure that they are functioning adequately. These assessments must be documented as part of your quality control plan. The check for eyewashes must include a flush of the system with water for 3 minutes. The check for showers might vary depending on the setup of your shower and kind of who does it and what kind of space you have for obvious reasons, because it can certainly make a mess. Eyewash showers should be cleaned weekly with an antiseptic. The temperature of the eyewash should be checked annually, and this is something that might be done by a department outside of lab, such as maintenance or plant operations. The temperature of the eyewash should be between 16 and 38 degrees Celsius. If you have purchased self-contained eyewashes in your lab, they must be within the expiration date indicated on the container. Outdated containers cannot be used even if they have never been activated or opened. For these types of eyewashes, and we do see these often, and we do use these in our lab a lot of times for some off-site, like procedural areas where we aren't necessarily coming in and we don't necessarily own the space, but we need to make sure an eyewash is available. In these cases, manufacturer instructions must be followed for that eyewash. These eyewashes are considered exempt from the weekly checks that were previously discussed, as long as the date indicated on the unit has not expired and manufacturer instructions are followed. And then typically when inspectors come in, they like to make sure that these instructions are, retained and available to them should they need to check really what it is the expectation is. In the unfortunate event of an exposure or accident, employees must act quickly in order to minimize the possibility of injury or permanent damage. For eye contacts, eyes should be immediately flushed with water for a prolonged period. After an employee has had a splash to the eyes, they should proceed immediately to the nearest eyewash station, remove the cover or caps, lower their head to the eyewash, and turn it on. They need to keep their eyes in the flow of the eyewash until they are completely flushed, which should be for at least 15 minutes. In the event hazardous materials are spilled on the employee's person, the employee should proceed immediately to the nearest safety shower or sink, depending on the extent of the spill and what's available to you. Skin contacts should be promptly flushed with water, with any contaminated clothing being removed as quickly as possible. The employee should remove any unnecessary or hampering clothing in order to fully flush the area and not recontaminate themselves. Personal safety should take precedence over modesty. Clothing may have to be cut off in some cases to avoid spreading a chemical to other parts of the body, with particular attention to the face by not pulling contaminated clothing up over the head. The employee should stand directly under the shower head or place their body part directly under the sink faucet and pull the shower lever or turn on the water. They should remain under the shower flow or sink flow, faucet flow, until the spill is completely flushed. In the situation of both eye and skin contacts, they should be reported immediately to laboratory leadership. If chemicals are ingested, the employee should be encouraged to drink large amounts of water. This will help dilute the chemical that was ingested, as well as promote its evacuation from their system. Again, this type of exposure should be reported immediately to laboratory leadership. In addition to staff being educated on steps to take in the event of an exposure, they must also be prepared to handle spills. Managing spills is important no matter whether the spill is minor or major. Every facility that uses chemicals must have a plan in place listing out the steps to take in the event of a spill. Labs that are part of larger organizations often have hospital policies and procedures that drive the majority of the process, and then the lab plans can be piggybacked onto these processes. The basic step of a spill includes clearing the area of unnecessary people and then cordoning off that area so that staff that were not involved avoid unnecessary contamination, inadvertently doing something to make it worse, or causing a subsequent accident. The spill should be assessed for type and degree of hazard, and then cleanup procedures should be followed. This will include reporting the spill to the appropriate team members. An important note here is in regards to spill kits. Spill kits must be used as determined by the manufacturer. Additionally, you want to check your spill kit regularly to make sure that it is not expired or the contents within it are not expired. If the spill kit does not have an expiration, there must be a record kept of the date the kit was put into service, and its usability must be assessed with this assessment documented on a periodic basis. The proper storage of chemicals is imperative to a good chemical hygiene plan and to staff safety. This is to ensure that your laboratory does not have a chemical event due to either the reactivity of chemicals or an unavoidable accident. Acids and bases have very specific storage requirements. Storage of these reagents must be below eye level so that staff are not reaching up into a cabinet or on a shelf and inadvertently tip the container onto themselves. Storage near the floor is recommended for both acids and bases in their own separate cabinets. Ideally, they should be stored separately in cabinets labeled with the word acid or corrosive, not under sinks, so as to avoid contamination by exposure. This separation avoids chemical reactions that could occur in the event of a spill. These chemicals should be labeled appropriately and handled wearing eye protection. Similarly, flammables also have storage requirements due to the nature of these reagents and the hazards associated with them. Flammables should have appropriate signal words indicated on their label so staff can identify the chemical as being flammable and take the steps to handle them appropriately. Additionally, cabinets that contain flammables should be appropriately labeled, stored with compatible materials and adequately vented. Flammables have restrictions in terms of how many gallons can be stored in a particular area outside of fire-resistant cabinets. There are additional restrictions based on the presence or absence of a fire suppression system. It is important to note what your lab allows based on the setup. Regardless of how you store your flammable liquids, you need to make sure that you understand how much flammable liquid storage is allowed in your laboratory based on its size. Flammable cabinets have a maximum storage of 60 gallons per cabinet, but there is a limit to the number of cabinets you can have in any given space. Flames or ignition sources must not be present in areas where flammables are stored or utilized. And if flammables must be stored in refrigerators, the refrigerators must be labeled to indicate if they are safe for storage of flammable liquids, and they must be explosion-proof. Flammables cannot be stored in regular commercial refrigerators. Formalin and xylene are chemicals that are predominantly used in the anatomic pathology laboratories and do introduce risk to our staff. It is important that staff understand the hazards and risks associated with these chemicals. Formaldehyde is the primary preservative or fixative used within the anatomic pathology laboratory. The solution is often used to fix gross tissue, autopsy specimens, and cytology cell blocks. Formaldehyde is a colorless aqueous solution that has an irritating pungent odor and is classified as an upper respiratory irritant because of its high solubility in water. Because of its unique nature to be able to vaporize in the air, OSHA developed a specific regulation, which is 29 CFR 1910.1048, requiring a written formaldehyde exposure control plan that describes how occupational exposure can be reduced through work practice controls, proper ventilation, the use of personal protective equipment, and periodic monitoring of air samples. So very similar to what is expected in the laboratory CHP. Formaldehyde has very specific exposure limits. There is the permissible exposure limit and the short-term exposure limit. The permissible exposure limit, or the PEL, is the exposure limit that is allowed over time and generally calculated over an 8-hour period. It is based on a time-weighted average, or TWA. OSHA defines a time-weighted average from the standpoint of an 8-hour period and then as an action level within that 8-hour period. So the limits that are defined are 0.75 parts per million within an 8-hour period. And at any point in time during that 8-hour period, the exposure should not be any greater than 0.5 parts per million. This latter measurement is called the action level. OSHA also defines a short-term exposure limit where within any 15-minute period, the exposure should not be greater than 2 parts per million. Initial monitoring of formalin vapors should also be performed in order to establish compliance and sort of set your baseline. Formaldehyde monitoring must then be repeated anytime there is a change in production or equipment, processes, if you increase your personnel, or any sort of control measures which might result in new or additional exposure. Periodic monitoring is mandated only if permissible exposure limits within an 8-hour period exceed the action level of 0.50 ppm or short-term exposure limit of 2.0 ppm. When these levels are exceeded, immediate corrective action must be taken to decrease exposure. Frequency of monitoring should be increased until there is assurance that the level of exposure is acceptable. Repeat monitoring should also be performed if employees note signs or symptoms of respiratory or dermal conditions associated with formaldehyde exposure. All data must be maintained within the quality control program within the department. Results of monitoring must be shared in writing with each employee within 15 days of knowledge of the results. If acceptable levels of exposure exceed the 0.75 ppm, a written plan to reduce the employee's exposure must be given to each employee exposed to formaldehyde. Each written plan must describe the corrective action being taken to decrease exposure, and medical examination might also be required by your employee or occupational health departments to assess acute and chronic effects from that exposure. Formaldehyde requires certain engineering controls in order to keep within permissible exposure limits and ensure employee safety. This includes chemical fume hoods, slot area ventilators, and local exhaust. Safe practice measures should be followed by staff that handle formaldehyde, including limiting splashing of formaldehyde, washing formaldehyde-soaked materials in water, maintaining the covers on specimen containers that emit formaldehyde, cleaning surfaces contaminated with formalin as soon as possible, and then strict prohibition of food and drink consumption and storage in areas where formaldehyde is used and stored. Staff handling formaldehyde must wear the appropriate PPE in order to ensure their safety, and this includes impermeable gloves, eye and face protection, lab coats and aprons, and respiratory protection. Xylene is another chemical that is commonly found in anatomic pathology laboratories and is used for processing and staining. It also carries its share of risks for those employees that must handle it. Xylene is a colorless, flammable liquid with a sweet odor. Exposure to xylene can irritate the eyes, nose, skin, and throat. Xylene can also cause headaches and dizziness. There is a requirement to monitor xylene fumes initially, but there is no requirement for periodic monitoring. Laboratories should consider repeat monitoring when there is a change again in production equipment, processes, more people added to a space, or control measures that are likely to increase or could possibly increase exposure levels. In an abundance of caution and for the safety of employees, this is always good practice. Xylene carries a permissible exposure limit as well as defined by OSHA, which is 100 parts per million over an 8-hour work shift, with a short-term exposure limit of 150 parts per million within a 15-minute period. Some labs have moved to xylene substitutes in order to minimize the safety risks of its employees. However, many labs still use xylene because of its suitability and effectiveness in processing and staining. Similar to formaldehyde, exposure monitoring must be communicated with employees as it occurs so that they are aware of the laboratory's compliance and their risk and safety. Employees must wear the appropriate PPE and engineering controls when handling xylene. These are similar to that of formalin. Laboratories must understand what is allowed in terms of chemical waste disposal. Not everything can just be poured down the drain with copious amounts of water. Formalin and xylene are good examples of chemicals that cannot be disposed of in this manner. While we're not going to go through every chemical available and how it should be disposed, we are going to review the manners in which chemicals are frequently disposed. Generally speaking, chemicals are disposed of either through normal wastewater or through segregated waste. The SDS should be consulted for the proper way to dispose of chemicals, but you must also be aware of any state and local regulations that might drive how you dispose of certain chemicals. If a chemical can be disposed of in the sink, you would flush it down the sink with copious amounts of water in order to dilute it as much as possible before it combines with the wastewater leaving your facility. If a chemical cannot be disposed of in the sink and must be segregated into a different container, such as xylene and formalin, you must obtain a separate container that is appropriately and fully labeled and put your waste in these containers after use. Outside companies are usually contracted then to come pick up the container that contains the waste chemical for disposal. So outside of chemical safety, which is one of the largest parts of any laboratory safety program, there are many other safety topics that a laboratory must address. As I mentioned earlier, we're going to talk about just a couple of them now, and then the balance in part 2 of this safety series. So the first major general safety topic we're going to talk about is fire safety. There is potential for fire in every laboratory, not only because of the chemicals we work with, but also due to all the equipment that is utilized throughout the laboratory. Most staff are familiar with the RACE acronym for fire alarm procedure if you discover a fire. And I kind of listed it out there on the screen in case you need a refresher. Try to remain calm if you discover a fire and use the RACE process to work through the situation. Stay between the fire and an exit to safety. Don't get yourself blocked into an area where you cannot get out. Walk and don't run when exiting, and be familiar with the post-evacuation process. Many organizations have meeting points or checkoff systems in order to determine who was able to evacuate and who might still be in the building. Facilities that we work with are so big and have so many different entrances, floors, hallways, doors, etc., that it is critical that an evacuation route has been identified and that staff know what it is. With buildings being added onto during construction, departments relocating, and staff transferring throughout the facilities, changes in evacuation routes are common as related to the staff. Awareness of your routes reduces your risks of getting caught in the building because that route has been determined to be the quickest exit for the location of your workspace. Make sure you know what it is. We talked about accidents and injuries as related to chemical injury earlier in this presentation. In all aspects of these sorts of events, I mentioned reporting immediately to laboratory leadership. This is such a critical step and often one that is skipped because staff don't feel like they need to, they don't feel like they have time, they forget to, and then don't address it when they remember. They don't feel like the injury or accident was significant enough to report. I could go on, but the key point I want to make here is that all accidents and injuries should and must be reported. This is the only way leadership teams are able to identify when processes are broken and put focus on finding solutions or fixes to the situations that are occurring and causing employees to put themselves in a safety risk. Laboratories are required to record and trend accidents and injuries that occur. They are often trended by the action, the personnel, the job code, and the department, to name a few. This data often drives changes that must be made either in education, engineering controls, product lines, or competency. There are many emergent situations that can occur and impact our laboratories. Depending on where your laboratory is situated, these situations likely vary. Emergent situations can include tornado, vehicular accidents, hurricanes, earthquakes, snowfall, use or presence of weapons or active shooters. Policies should be in place to address these kinds of situations as applicable to your facilities. Again, like with just about everything else we have reviewed so far today, policies help educate us and serve as a resource for events that don't usually happen often, but are events that we need to react to sometimes quickly. These policies might include what lab's role is in the situation of a bigger event that the larger facility might be involved in, such as vehicular accidents or events that might be happening in the emergency room. Electrical equipment is prevalent in the laboratory and can be a cause of fire and/or injury to our staff. No different than when you first bring a new appliance into your home. When we first bring equipment into our labs, we must ensure that it works properly and is safe to use. Then, on an ongoing basis, we make sure that it is functioning correctly and safely. Laboratory instruments and appliances must be adequately grounded and checked for current leakage before initial use, after repair or modification, and when a problem is suspected. Plugs or cords should regularly be checked to ensure that they are not frayed or worn, and if they are, they must not be used. Loose connections and frayed wires should be reported via the process set out by your facility. And most facilities have like a biochemical or a biomedical department or something similar that have experts to address these sorts of issues. Never handle electrical equipment when any part of your body is wet. Do not stand on a wet floor when handling electrical equipment. Be sure to turn off and/or unplug all instruments before attempting any repairs. Power cords of portable electrical equipment should be visually inspected for external defects whenever relocated. Grounding configurations cannot be bypassed by, for example, an adapter that interrupts the continuity of the grounding. If manufacturers' recommendations for grounding are available, they must be followed. In general, extension cords should not be used in the laboratory as they introduce a safety risk. And then finally, grounding of instruments includes everything in the laboratory, including your household type of appliances that are often used, such as coffee pots and microwaves. So after all of this discussion on the various safety topics, it is important to note that it is not enough to just have policies in place to say we are going to do this or we're going to do that. There must be a program that attempts to mitigate safety risks through monitoring. I'm going to share with you pieces of our monitoring program in the next few slides. So the next 4 slides contain screenshots from a monitoring form that we use on a quarterly basis in all departments of the laboratory. We assign various people throughout the lab, and generally it tends to change so that we have an unbiased look at things, to monitor the various activities as listed on this form. Then the administrative and medical directors sign off on this form, and it is sent to our safety officer for the system, who then reviews it and addresses any items where corrective action or follow-up is necessary. Items are then brought to the lab safety committee meeting for discussion as necessary. So as I scroll through the 4 pages of this form, you'll see the areas that are addressed are items that are frequently found as high-risk, problem-prone areas that we want to make sure we have compliance with our staff. A key element to point out here is that while we have policies and procedures in place for all safety risks in our labs, it is also our responsibility as an organization to educate and determine compliance amongst our staff, as well as implement performance improvement initiatives. This is one way we are able to gather data and take action based on findings and behaviors observed. So as I kind of scroll through here, you can see the general layout of the form, the criteria that we're looking for, what the compliance is. We do document the date, any comments the surveyor may have, and then we document that corrective action in that last column. So if you look at things like this is sort of a combination, and we'll talk about this in part 2 as well, of kind of our bloodborne pathogen assessment as well as our chemical inventory or our chemical safety assessment. So things like, and then some of the general safety items, such as item number 16, we're looking at our fire extinguishers. Item number 17, this is where we go to the employees and say, hey, tell us, show me how you're going to pull up a safety data sheet, and we actually make them go through that process. Item number 18, looking at eyewashes and showers and making sure that they're being checked like we say they're being checked. 20, 21, and 22 talk about or look at the electrical equipment safety and look at our flammable materials and how those are stored. Moving on here at the top, item number 25 looks at xylene and formalin. We go into these departments and into the pathology department, and we actually ask them to make sure that they are monitoring for these 2 chemicals. And then kind of rounding out this portion of the safety discussion, we look at line item number 29 and 30, where we do go through and take a look at our first aid kits and our spill kits. We look for expired items, and then we do look at our evacuation routes and make sure that they're posted and that they're up to date. And this is just the final part of the form where we have the administrative review and then the medical director review. So these last two slides demonstrate excerpts from an activity we have the staff perform annually. Again, this is assigned to certain people each year for each department. And the expectation is that this tool is used to document both the chemical inventory of the department, and then a broader safety review is done at that time as well. Essentially, this is the tool we use to evaluate chemicals used in the laboratory for that carcinogenic potential, reproductive toxicity, and acute toxicity. So this first page is just kind of that general assessment of asking the departments to do that review of their chemicals to make sure nothing's been added or removed that might impact our employees' safety. And then this second slide, again, this document is actually quite lengthy, but this is just the first page, or one section actually, I think, of some of the safety items that we might take a look at in terms of our chemical safety. So, item number 6 talks about chemical fume hoods and is the annual certification there. And then some of the other things are bloodborne pathogen things that we'll talk in the next series. But this is our way of really doing that assessment. Again, we try to assign this to different people so that we get a different perspective of it each year or each quarter, depending on which assessment that we're looking at. Oh, and this just lists my references. So with that, I will conclude by re-emphasizing the importance of having a solid safety program in place for the laboratory. Additionally, the responsibility for laboratory safety lies with the leadership team to establish and monitor, but also with us as laboratorians to hold ourselves and our fellow coworkers accountable in our daily work activities. We are exposed daily to many hazards to our health and safety. This presentation focused primarily on chemical safety, but there are also biological safety hazards, of which we will talk about next month. It takes everyone doing their part to keep the risks we are exposed to daily to a minimum, knowing that we already accepted a certain amount of risks when we entered the field. I hope you found this presentation worthwhile and valuable. If you have any questions, please feel free to contact me at my email address indicated in this last slide.